Okay, now we're finding the vector equation of a line. And the theory we need, came up before, it's this thing here. The equation of a line always starts r equals. It's not just this bit, it's the r equals bit as well. But the thing I need to set up is a vector, a column vector here, which gives me a position vector of a point on the line, plus a parameter, times a direction vector, okay? You can use the letter lambda if you want to, but also you see letters like S and T being used as well. Okay, but that's going to stay as a letter, and R is going to be either R or X, Y, Z. It's the position and the direction we need. So the template for a vector equation, this should remind you of when you did straight lines in Core 1, you needed a point and a gradient. Well, we need a position, which is effectively a point again, okay, but the equivalent of a gradient is a direction. So that's my template. I need to find a position, I need to find a direction, then I'm ready to set up the equation of the line. So a position of a point on the line. Well, A's on the line and B's on the line. I mean, here's the line. A, B, goes through A, goes through B. So I've got a choice. There is not just going to be one correct equation. Depending on the choices I make, there's more than one, okay? But the obvious point to choose is the first one, A. So the position I can have as the vector 137. I'm just using OA, okay? So the origin is somewhere over here, okay? So the position vector that gets me onto the line, okay, might not point along the line at all. Its job is to get me from the origin onto the line. But then, if I just stopped there, I'd only ever get the point A. I've got to be able to get all of these different points along the line, and to do that I need to move backwards and forwards some distance along it. So that's where the plus lambda d bit comes from. So the job of this part is to do the work of getting from the origin onto the line. And then this part, depending on what lambda is, I can do any length vector I like in the direction of the line, either that way if lambda's positive or that way if lambda's negative. Okay, so I need, for this d, just to have a vector that points along the line, and the obvious one to choose is the vector AB. So for the direction I'm going to use the vector AB, which is OB minus OA. That recipe is coming into nearly every question. Okay, AB is OB minus OA, which is 358 minus 137, which I've done before. I've worked with these 2 points before. 2, 2, 1 is looking familiar. Okay, so I've got a position, I've got a direction. Okay, now using this template, okay, I've got a recipe for setting up the equation of the line. So I've got R equals, but remember, instead of R, I'm using R equals A plus a parameter times D, lambda times D. So I could write R, but I'm going to write X, Y, Z instead. Okay, equals, my A I've got is 137. Okay, my plus lambda, I could use lambda, but I'm going to be a daredevil. I'm going to use T instead. Okay, and my direction vector I got is 2, 2, 1. So that is my equation of the line. There's no rule about what letter to use for the parameter. You can use T's and S's if you like. If you don't like Greek letters, and yes, it would have been right if I'd had B here, and there are other changes I could make, but this is okay. Notice it's got to have this R equals bit. I don't care whether this is written as R or X, Y, Z, but if it's not there, if you give that as your answer, it's wrong, all right? You have to give a complete equation. Clue is an equation has to have an equal sign in it, and it has to have something before that equal sign, okay? So expect a great deal of sarcasm if you just give that as your vector equation of your line. It's wrong.